We need to find derivative of y with respect to x whenever y is given by an infinite series as square root of x raised to the power of square root of x, which is again raised to the power of square root of x, and this goes all the way up to infinity. So let's begin. So here we can represent our infinite series as y equals to square root of x. Now instead of raising it to square root of x again and going up to infinity, we can simply replace it with y. Such that we have y equals to, so square root of x can be also represented as x raised to the power of half whole raised to the power of y, or simply y equals to x raised to the power of y over 2. To find out derivative of y with respect to x, what we'll do, we'll take the help of logarithm. So such that we can do a logarithmic differentiation. We'll take the natural log on both sides. So we have log of y equals to log of x raised to the power of y over 2. Now we will use a property of logarithm that states that whenever we have log of a raised to the power of b, this is equivalent to b times log of a. So that means we can rewrite logarithm on the right hand side as y over 2 multiplied to log of x, or simply 2 times log of y equals to y times log of x. Now we'll take the derivative. So let's label this as number 1 and this as number 2. So we'll begin with equation number 2. And we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of log of y, which will be equals to derivative with respect to x of y log x. So with that, we have 2 times derivative with respect to x of log of y equals to, so here we can use the product rule. So we have y multiplied to derivative with respect to x of log of x plus log of x times derivative of y with respect to x. We're going to use the fact that derivative with respect to x of log of x, this value is equals to 1 over x, such that we have 2, the derivative of log of y will be 1 over y, but since we have an y here instead of an x, we'll need to use the chain rule. We'll multiply it to derivative of y with respect to x, which will be equals to y over x. That means we have derivative of the logarithmic function giving us 1 over x plus log of x times derivative of y with respect to x. We'll transpose this second term from the right hand side to the left hand side. So we get 2 over y minus log of x multiplied to derivative of y with respect to x equals to y over x. Right. We can combine the two terms within the parentheses to get 2 minus y log of x divided by y times derivative of y with respect to x equals to y over x. Since we need y over x, derivative of y with respect to x, so this is going to give us y squared divided by x multiplied to 2 minus y log x. So this is going to be derivative of y with respect to x, where y is given by the infinite series as given here.